We can express this process of addition of binary integers in the form of an algorithm. So here is the pseudocode for this algorithm, which can be coded in any language of choice. Alright, so we have these two numbers a and b, which are expressed in the binary format, and we want to sum these numbers. And we assume that the carry in for the first stage is 0 because there was no previous bits being added. And then we have a loop which goes which runs once for each bit in the summands, the operands of the sum. So in each stage we compute the sum of the relevant bits and the carry from the previous stage, and this sum is then converted to the most significant bit and the least significant bit as follows. So how do we get the MSB from the sum? Remember, this number e is either 0, 1, 2 or 3. To get the most significant bit, we divide it by 2 and ignore the fractional part. This gives us the most significant bit. And most significant bit, as you may remember, forms the carry of the next stage. So we update the carry to be equal to the most significant bit of the sum of the bits of this stage and the previous carry. Now how do we get the least significant bit? Because that will form the current sum bit. Okay. For example, in the first stage, when j equals 0, s sub 0 will be formed by the least significant bit of e. So an easiest way to get this is to remove 2 times MSB from the sum e. Okay, so this gives us the least significant bit. For example, if e was 3, then it will be like removing 3 minus 2 because the MSB is 1, will give us the least significant bit. And this least significant bit will then will have the role of the jth bit in the sum. And we repeat this process and we access more significant bits of the two operands, and we update the carry at every stage, and the carry at the last stage, when the loop breaks, will form the most significant bit in the sum. So the most significant bit of the sum will be the carry out of the last stage.